And now it's time for our guest, Zach Weinersmith. Welcome to the Weekly Space Hangout.
Thanks for having me.
So for people who have no idea who you are and what you do, give us the intro.
Sure. I'm best known, I suppose, for I draw a comic called Saturday Morning Breakfast Cereal, which is a kind of nerdy, daily updated gag comic strip. And then what else do I do? I run a show called The Festival of Bad Ad Hoc Hypotheses, which is a sort of fake science show. The title gives you a sense of how dorky it is. And then recently with my wife, Dr. Kelly Weinersmith, I wrote a book called SOONIsh, which is a sort of humorous but actually well researched, I flatter myself, book on future technology stuff.
And I mean, a lot of anyone who's read your comic knows that you spend a lot of time in the realm of science with what you write and what you draw. So tell us sort of what Soonish was about and working with a doctor.
It was about we picked like 10 areas of technology, and then kind of just really dorked out about and read a lot of like really painful primary literature, and then put it in a bunch of comic strips, hopefully to buy us some of that depth and patience from readers. And in terms of space stuff, the relevant space stuff we did one on ways you might get to space more cheaply, most of which were non-rocket methods, though we did talk about reusable rockets. And then we talked about asteroid mining. And then we talked briefly about space-based solar power, but in the context of deciding it was probably a bad idea. So I can talk about all of those things. We also very briefly talked about, we happened to, while researching a section on 3D printing food, we found this project that NASA was paying money for people to do about turning human waste into food for astronauts, like their own waste, not just anybody's.
Waste.
Yeah, but it was funny. We mainly put it in the book because the title of the project contained the phrase "closing the loop," which is just delightful. So those are the things I suppose qualified to talk about.
So what are the 10 technologies overall?
Just them. I got to pull up my own book here. I always forget something.
I know what that's like. You write a thing and then literally minutes later you can't remember what it is that you just wrote. You drew comic books. You drew comics about this. You spent a lot of time on this.
A lot of time. It doesn't matter. We do cheap access to space, asteroid mining, fusion power, programmable matter, robotic construction, like of buildings, that sort of thing, augmented reality, synthetic biology, precision medicine, and bioprinting. And brain-computer interfaces.
So, in the subtitle of the book is 10 emerging technologies that'll improve and or ruin everything.
Yeah.
So, which has the greatest chance of improving things, do you think?
I suppose it depends on what you want. Like, I'm about to probably become a homeowner, so the idea of having robots build my house is pretty engaging at the moment. Although probably not the most useful for everyone. Probably any of the health stuff. We have a chapter on bioprinting of like replacement organs. So there's like about 120,000 people in the U.S. are waiting on an organ right now, and a lot of them aren't going to make it while they're on the list. So being able to do that would be pretty, quite literally life-changing for people. But if you don't want to do the nice thing, well,
that was going to be my second question.
Yeah. I mean, actually, in terms of life-changingness, probably brain-computer interfaces, because that's like making humans sort of unrecognizable over the long term, which I guess is good. I don't know. Depends on how you feel about humans, I guess.
And so, which is the one that has the highest likelihood to ruin everything?
Ruin everything. I usually either pick brain-computer interfaces, or I hate to say, we wonder a lot about cheap access to space, because it's very exciting, but I'd love to get y'all's thoughts on this. But our concern was, you get into this situation where it becomes very easy to weaponize space, because all these planets are just gravity wells, including Earth. So if you have a rock in space, you can just throw it down, and it's pretty hard to stop unless you notice it early. Like I don't think we get too much into this in the book, but it's arguably worse than like a nuclear missile, because at least with a nuclear missile, you have the potential to like slam the warhead. But if someone drops 1,000 tons of metal from orbit on towards the city, you're pretty well toast. Like the solution's probably worse than the problem. And that seemed to us like there's probably not a science fix for that, at least not one in anywhere like the near future. That's probably a geopolitical fix, which is, at least at this moment in history, doesn't seem like a thing we're particularly good at.
Well, I don't know if you've read the Outer Space Treaty, but the gist of the Outer Space Treaty is whatever you do, don't put weapons in space. That's that's like every second sentence is, and by the way, no space weapons, because that's bad.
Yeah, well, so two things about that. First, the Outer Space Treaty, the way I like to say it is it's very Kennedy-ish. There's like, also, to give you a sense of how like utopian it is, there's a passage in it, I think, that literally says, we'll only use space for the benefits of mankind. And it's like, everything away from Earth will be used for the benefits of mankind. We've completely failed to do that down here, but the rest of the universe, we're going to get it right. I find that a bit implausible, let's say. But the weaponizing space thing, I mean, to me, that's the scary thing about cheap access to space, because everything's a weapon at the top of a gravity well. So you don't need to get a missile up. A terrorist with a big honkin' rock can do it. There's this idea in the Cold War called a rod from God, which was you make like a cylinder. Maybe you've discussed this before. You get like a tungsten cylinder that weighs whatever 2,000 tons. Something, and you know, it's easy to conceal because it's just a freaking piece of metal. You might have used it structurally, but instead you toss it down at New York City. So that's a scary thing. I
mean, I think the trend for all of this stuff, when you think about all of this, is that they're all moving towards this democratization of the technology, that every single one of these things, be it 3D printing organs or 3D printing killer viruses, getting robots to build your house, or getting robots to exterminate humanity, 3D, launching your spaceship to go and mine an asteroid, or using an asteroid to kill humanity. That what this technology is doing across all of them is it is making it easier for individuals to contribute in meaningful ways, and you can decide what the word meaningful means.
Yeah, exactly. Yeah, there's some things one would not like democratized. There's some things I'm glad are handled by boring experts, such as nuclear weapons. But yeah, like you say, if you get to some sort of like really advanced future where you can just spin up molecules, there's all sorts of creepy stuff you could make at your home, like viruses or modified versions of pre-existing viruses. And there's this general problem of like, how does that get controlled? And I don't know that there's a good solution that's not ultra invasive, and maybe that's just the solution.
Well, yeah, I mean, it sort of leads us towards an explanation for the Fermi paradox, or the great filter, that that we kind of, as our technology improves and increases, and as more destructive capability is put into the hands of more and more people, you get to this place where it's inevitable that when you're mailing out destroy the Earth buttons to everybody, that somebody is going to press the button, right?
Yeah, I feel like what I'd want to know if we met 100 alien civilizations is like the percent of civilizations that survived the nuclear era, and I wonder if it's pretty low and we're just lucky, because you could think of all the times we got lucky in the last 70 years that we could have all got blowed up, but somehow didn't.
Well, you think that, I mean, you think about the risk of nuclear weapons compared to down the road, somebody, everyone in their garage creating their own artificial intelligence and having them battle out there, or everyone being capable of designing their own custom life forms and then just kind of releasing them into the wild to see what happens. So that's that's what I think about all the time. But now, what was it? I mean, as doing a book, you get a chance to do some research, you get a chance to kind of go behind the scenes and see what people are working on. Were there any of these that you got a chance to look into or talk to some of the researchers, and just by like you were shocked at how well this technology was coming along?
Let me see. I mean, most of the stuff we researched was pretty far out. The two that were starting to get really interesting were one, augmented reality, which is starting to get a little money after a lot of years in the wilderness, and the other was precision medicine, which is the short version is it's like when you go to the doctor, instead of doing the usual checkup, you'll get like a sort of molecular test that you run a lot of stats on to figure out what problems you might have. And both of those have a couple, you might say, economic advantages over the other stuff, which is, to have a really good market, you need to have a system where just slight improvements are worth it to people. Like with computers, or like a phone, like we'll all apparently, pay an extra $600 for a 2% improvement on a smartphone every year. And that makes for a healthy market, at least for the producer. So that's kind of true in augmented reality. We're starting to see games, but also applications for like work training, civil engineering, eventually surgery, although I don't know if that's been tried, for real yet. And in the case of precision medicine, there's all this really exciting stuff. Like if you just like Google Scholar for microRNA detection, like there's a microRNA signature for like everything, like every cancer. Like you can predict a heart attack by detecting dying heart tissue, like a week out maybe. There's all sorts of super cool stuff. It hasn't been commercialized much yet, so we'll see. But there's a lot of exciting action.
Now, your wife, as I mentioned, the doctor of the family, what's her background?
She is currently adjunct professor at Rice University, and she studies parasites that manipulate host behavior. And actually, they just had Ed Yong had a piece which was pretty exciting about her and a colleague just discovered a new species that's this like creepy parasitoid. So, but that's what she does. Yeah.
Yeah, I don't want to know any more. Actually, Ed's got a new YouTube series to go along with his book. So
I didn't know that.
Yeah. I think he's got like a set of like 20 separate individual episodes, each of one which kind of matches something that's going on in the book. Just a good idea, something to do for if anyone's doing a book.
Yeah, interesting.
So what was it like then to kind of have her perspective on this stuff coming from a medical background?
Well, it's not so much medical. She's a theoretical ecologist, so it's more of an ecological background, but still, it was certainly useful. We have kind of complementary interests, which is she likes researching more and I like writing more. We both did both, but also just a lot of the biology stuff in the book was by her. I have a little bit of a physics background, so I think it was a little easier for me to do more of the space stuff. But to be honest, at the end of the day, the really useful thing is having a collaborator who actually works and communicates and is relatively mature most of the time. That's a pretty hard thing to find. So that was the sort of deep thing. We did have. She also knew how to do a lot of research stuff and a lot of like how to properly do footnotes and organizing your bibliography, that sort of thing. A lot of the proper technical stuff you're supposed to do with these sorts of books.
Right. The kinds of stuff that, I would absolutely just not even think about.
I would just cry.
You're just like, I don't know how to do this. What am I supposed to do?
I don't know how to do it. Yeah.
Can't we just pretend?
Right.
So book just came out. Where can people find it?
It's our first book through a traditional publisher. It's through Penguin, so you can I can say you can find it at fine bookstores everywhere, or at least bookstores. I don't actually know what a fine bookstore is. I think that's like an old thing. But it's in regular bookstores. It's also, of course, on Amazon, and I think on Barnes and Noble you can get a signed copy. And on like if you're anti-establishment, you can go to IndieBound or something like that. So pretty much everywhere, it's relatively easy to lay your hands on a copy of this one.
And of course the comic, which most people will know you from. How long have you been doing that now for?
Oh God, it depends on when you designate the beginning, but quote unquote professionally for about 10 years now. I think this is the 10th or 11th year. Mind you, in the original years, professional meant like I could make rent and kind of eat. So.
That's where you draw the line when you get to eat?
I have a real I'm a total narcissist, but at the same time I have this sort of bug about like it took me a long time to be willing to call myself a cartoonist because I'm like I don't know, there's this thing now where you're supposed to be like if you've written a word it's okay for yourself to call yourself a writer, and I don't know, I don't feel that way about myself. I don't care what anybody else does, but I feel like I have to be doing a good job of it before I get to call myself a thing.
Right, and you'll never think that you're doing a good job of it, so you'll never be able to call yourself. That's fine. I don't trust anybody that doesn't have that complex.
Oh, yeah, totally. Well, you know what it is too? It's like, not only do you have that complex, but I actually feel like the complex is useful. I think I could have like psychologized my way out of it, but I'm like, well, I don't know. This keeps me productive. Like a certain level of self-hatred is sort of valuable for efficiency.
Yeah. There's nothing to motivate you like your imposter syndrome. It's perfect.
Exactly. Yeah. You have to earn it every day. Yeah.
All right. So where do people follow you on all of the things?
All the things. I'm on Twitter at Zach Weiner. That was before I got married. I'm now Weinersmith, but at Zach Weiner. And then our Facebook page is just /SMBC Comics, like the website. And then my website is smbc-comics.com. And then that show I mentioned is BAHFest, the Festival of Bad Ad Hoc Hypotheses. That's BAHFest, like festival.com.
Fantastic. I've got one question that just came in from a fan. I was going to throw this in. How do you pick topics that would be? This comes from Arjone. How do you pick topics that would be good to illustrate or make fun of? Where do you get your ideas?
Is that in reference to the comic or the book? Or,
I'm going to assume the comic.
Okay, if it's the where do you get your ideas question, what I usually say is I like to steal them from dead people. So I, which is close to the truth. I read a lot, and I try to. I haven't been able to do this because we've been on a book tour and it's driving me crazy. But I usually try to read like 3 to 5 books a week,
Wow.
If I can, like hard stuff or weird stuff or stuff other people aren't reading. I'm that guy. It's funny. I'm working on a project. I'm illustrating a comic book with another guy now, and he's a comics geek, and he was asking me like, "Have you read this? Have you read this?" And I was like, "I haven't read a damn thing," because I have this thing about I don't like to read what other people are doing right now because I worry I'll kind of get in the same pool. So I read like older stuff, and it's funny because I feel like when I say that I'm like doing the hipster thing, but I'm just like I have this paranoia about copying other people's ideas.
No, I have the exact same paranoia. There's all these YouTubers that I would love to watch their work, but I can't do it because I know that I'm gonna they're gonna infect my brain, and so I've got to. I go like, hey everybody, Isaac Arthur just came out with a new video, and I would love to watch it, but I can't, and I'll wait. I'll wait until I retire, and then I'll get a chance to just catch up on all this stuff.
Yeah, catch up on 40 years of
YouTube, of missed YouTube, and I'm assuming it's good, and I'll tell everybody all about it, but I won't actually read it. No, the thing that's been working for me is I take a book and I get through 10% of the book every night before I go to bed. And I sort of set that as my, and that I've been making my way through a bunch of books recently, but I kind of never feel like I have enough time. But the problem that I get is then you get too many ideas.
Yeah, right? Yeah. Well, that's true. And well, for me, it's like I consider my job essentially to read books, so I'm able to do a lot. But yeah, the problem is, for me, I have to put out a comic every day, so I've never had the feeling of having too many ideas. But that sounds nice.
Yeah. All right. Well, Zach, thank you so much for taking the time to talk with us today. Good luck with the book. Congratulations. It's an amazing accomplishment. And
thank you,
everyone. I'm going to put up the people on the podcast. We'll just have to imagine we've got like a sound effect. Can you hold up the book?
Oh yeah. There's the book, and then I'm going to do a sound effect.
There you go. That's for the podcast.
Doesn't that sound good? Don't you want to buy that?
All right, Zach. Thanks a lot. See you later.
Thanks a lot. It's been a pleasure.
Okay. Oh, you hold on to that, Morgan? All right. All right, so now it's time for us to go back to the beginning, and we'll do the intro of the show, and we'll go from there. Give me 1 second. I'll stop that recording. Okay. What's the time right now? 19:29. Okay, I'll tell Chad this.
Hi, Chad.
Hello, Chad. All right, here we go.
Hi, Chad.
Put that in front of me. All right. Welcome to the Weekly Space Hangout for Wednesday, November 1st, 2017. My name is Fraser Kane. I'm the publisher of Universe Today. This week, we're going to be talking about Saudi Arabia's investment in Virgin Galactic, evidence of an ocean on Ceres and the White House's pick for a NASA administrator. Joining me this week, we've got Dr. Morgan Renberg, the Director of Scientific Presentation at the Fort Worth Museum of Science and History. Morgan, welcome to Weekly Space Hangout.
Hey, Fraser.
Do I say welcome? Hey, Morgan.
I feel welcomed. That's what matters.
You've been well welcomed. And joining me as well is Dr. Kimberly Cartier. Hold on. Earth and Space Science reporter for EOS Magazine. Kimberly.
Hey, Fraser. Hello, all you podcast listeners. Happy Podcast Day.
Is it Podcast Day already?
I'm going with Happy Podcast Day because it's Wednesday for all the or Thursday morning for all the live listeners, but for all of the podcast people, it could be any day ever.
Well, right? Isn't every day? Isn't every day's Podcast Day, right?
Well, this is the day we record the podcast, and this is the day our listeners are listening to the podcast. It's a catch-all.
So before we get into...
Now that we've overanalyzed that statement.
Yeah.
It took me a while to come up with that.
Before we get into this week's episode of the Weekly Space Hangout, I just want to remind everybody to get out there and join the Weekly Space Hangout crew. That's, of course, the community for to go along with this show. They're the ones who organize some of our stories. They pick our guests. Once again, later on, you're going to hear Zach Weinersmith from Saturday Morning Breakfast Cereal. And I didn't pick him. You did. So thanks for organizing this guest. That was great. He's a terrific guest. Go to wshcrew.space and you can join up. Totally free. All right. Let's get on with this week's stories. First up, Morgan. Let's talk about Saudi Arabia's investment into Virgin Galactic.
Yeah, that's a name that we haven't heard in a long time. If we went back, a bunch of years, Virgin Galactic was basically the only game in town when we were talking about trips to outer space from commercial companies. But they sort of have fallen below the radar when it comes to the daily drumbeat of space exploration news. And now we talk a lot more about SpaceX. We talk a lot more about Blue Origin. But it's worth going back and thinking about Virgin Galactic because they're doing things totally different than everybody else. And it's really kind of awesome to see a whole different conception of how you might get to space. Remember, instead of launching on a vertical rocket like Blue Origin or SpaceX is trying to do, Virgin Galactic is going the spaceplane route. And they're not just doing a boring spaceplane on a vertical rocket. They have a spaceplane attached to basically a giant airplane that flies them up to cruising altitude, drops the spaceplane, and it then, in theory, rockets forth to achieve space. And like the New Shepard from Blue Origin, this is not an orbital mission. The idea here is to lift up a crew of paying guests to experience a few minutes of weightlessness before coming back down, hopefully safe and sound to the Earth. And I don't know about you, but somehow this feels both cooler and less cool as a space tourist than sort of the Blue Origin SpaceX model.
Well, just to give you some context, when you think about timeline, the Ansari X Prize was won by Scaled Composites in, you ready for this? 2004.
It seems like they seem so close to guests flying on it after that. It seems like we're just a few years away.
It's been 13 years since the X Prize was won, and then they started working on Spaceship 2. So, I would certainly in the near term get on the space plane before is that the question? Would I get on the space plane or the capsule?
Yeah, I guess. I mean, which would you feel sort of safer in? And then which seems like a cooler way to go to space?
I like the space plane.
Space plane is pretty cool.
Yeah.
I would say you can't really beat a vertical rocket in terms of the coolness factor or in terms of the classic launching up into space. I feel like anytime you have an image of we're launching something into space, you think, vertical rocket. But space actually isn't that far away. You can get to it from a space plane, sure. I think the thing that, I had to refresh my memory what the heck Virgin Galactic was doing.
Oh.
As I was refreshing my memory and learning about this new contribution from Saudi Arabia, I was like, they don't have like a single destination. That's what we've been talking about for the past few weeks is, we're going to the moon. Oh, we want to go to Mars. Oh, we're not doing asteroids. All the other programs we talk about are, what do we have to do to get us in orbit around this object or landing on this object? And that's not really what Virgin Galactic is doing, is it?
So, for a program that is, in its 13th year now, it's maybe not surprising that they need more money. And they need a lot more money. Flying to space, whether by plane or by capsule, is a pricey thing to do. And they have just secured a $1 billion investment from the government of Saudi Arabia. And this $1 billion investment buys the country a sizable portion, basically, of this space program, but not enough to take it over. So Richard Branson and the rest of the Virgin folks will remain the controlling interest in the project. And they've sort of been on the defensive this week because of the human rights record that Saudi Arabia has, and whether, for a country that, has a lot of legitimate questions about things like, are they using slave labor to build their cities? Are these the people that you want to be taking $1 billion from and sort of giving them a flashy thing to show off? And they've been pretty firm that, this is a company that's going to retain the values that it's already had. But certainly this is not, I think, the attention they were expecting to get when they announced this splashy $1 billion investment.
Yeah, I mean, I think that, I'm not sure what your guys' perspective of Richard Branson is, but, of all of the billionaires out there, he feels like one of the most sort of cosmopolitan and global-minded and concerned about human rights and the devastation of tropical islands and things like that. So I can see the stances that Saudi Arabia, I mean, obviously the easy joke to make is, will there be female pilots permitted?
But that's actually a legitimate question.
Yeah, no, I know. That's what makes it easy. It can be a joke and a serious question.
Yeah, and it's interesting, specifically coming from Virgin Galactic, because, I agree that Branson seems sort of more worldly and cosmopolitan than, say, Elon Musk does. But SpaceX and Blue Origin, I think, have sort of shrouded themselves much more in the mantle of sort of, we're out to save the world. Virgin Galactic has never really seemed like anything but a nifty project to make a buck. Branson's a businessman through and through.
Yeah, it's a commercial project.
Yeah, has never really pretended that he's trying to, advance humanity in any sort of meaningful way. He just wants basically to make a fancy amusement park.
Yeah, no. Just to be clear, I'm not saying that he's, that he is more environmentally minded than even, say, Elon Musk, who has dedicated his life to electric cars and solar power plants and all of that. More, perhaps more compared to, say, gas oligopolies and billionaires from the traditional world, right?
Yeah, this deal gets even interesting, or more interesting, because part of the contract for this $1 billion investment is an option to the Saudi government to contribute just under another $500 million sometime in the future. And if they do that, then Virgin Galactic will carry out at least some of their launches from Saudi Arabia.
Right.
So right now in the current venture, this is being built in the United States. It's planned to be launched primarily in the United States. But if Saudi Arabia kicks in another $500 million, we're going to be talking about launches that are taking place in their country and therefore governed by their laws and their customs. And so they might say right now this is where we are culturally. But if, they've opened the door to basing a tremendous portion of their operations in a country that doesn't have the best human rights record.
So what does this mean then? How is this going to play out? They gave Virgin Galactic $1 billion. Virgin Galactic gets to keep developing their technology. Some of the rockets will be, some of the facilities will start to move to potentially Saudi Arabia. How does this play out, do you think?
So they're saying that within the next few months, their space plane will go into space for the first time. And you might recall that they were pretty close to that point a couple of years ago when they had a fatal accident in which the plane broke apart, killing one pilot and badly injuring the other. And so it's taken them a couple of years to build a new plane, run through testing, do the glide tests to make sure that the aircraft is structurally sound, all of those things. And they claim now that they're a few months away from going into space. And Richard Branson himself, just in the last month, has said it could be as little as 6 months before he is riding one of these into space. And I would take that with a huge grain of salt, because just like SpaceX, just like with Blue Origin, there's a tremendous amount of schedule slippage along the way. This, again, was a project started in 2004 with the goal of having people flying, sort of within the decade. And we've exceeded that and still nothing. So the idea is that they're moving pretty close, but it's not quite there yet. And this is just actually one of two projects that they're working on, because another project that has really flown under the radar, in fact, I don't think we've ever talked about it on the Weekly Space Hangout, is they're also looking to compete in the orbital satellite launch market, but again, in a totally different way. Rather than the Blue Origin, SpaceX, ULA model of build a big rocket, launch big spacecraft, they're building a little rocket that's going to launch satellites up to about 200 kilograms. And that's really small. When we talk about something like the Falcon 9, we talk about tens of thousands of kilograms being the sort of upper limit of that. And we're talking about many, many tens of thousands of kilograms for something like the Falcon Heavy or the Space Launch System. So now and they started this project before this reusable rocket era really sort of took off. And I think there's serious questions now that if SpaceX and if Blue Origin are targeting launching a single rocket 100 to 1,000 times and really driving down the cost of a single launch, whether it's even going to be cost competitive to launch a single 200 kilogram satellite when you can launch 100, 200 kilogram satellites on one rocket and reap all of those economies of scale.
Right. Or just launch your 200 kilogram satellite on a reusable BFR and only pay for the price of the fuel and have it land again and then put another one on top. Like, if indeed these things are launching and it's only going to cost them a few $100,000. I mean, I think they say the price of fuel for a Falcon 9 at this point is about $200,000 is just the fuel alone. And if these BFRs are literally making their fuel from the atmosphere and solar power, then who knows what the actual cost of the fuel are going to be. So it is a good question. But I mean, I've seen a bunch of these providers. There's one out of New Zealand. I know the Japanese are working on a small sort of payload rocket as well. There's a bunch of these starting to come together. We're getting a launch facility in Canada that's going to be doing the same thing, but aiming more towards polar orbit. So it's funny. I think you hit the nail right on the head that at the same time that Musk just said, that's it. All of your other rocket programs are pointless. This is the one to rule them all. All of these other groups are coming out with their smaller versions of rockets, trying to edge in on the side of the launch space.
Yeah, and and SpaceX is going not only with just one rocket, but with the biggest rocket.
Yeah. Yeah.
We couldn't have more diverging paths here between people building these tiny little rockets to launch tiny little payloads, and SpaceX building this enormous rocket to send people to the moon and to Mars, and to launch your mom's communication satellite.
I'm amazed that with the money, I mean, you can see that Dubai and Saudi Arabia and a lot of these oil-rich countries have a real interest and drive in being able to get into the space race. And Dubai has been putting out a bunch of stuff about how they're going to be building cities on Mars and stuff. That I'm surprised. And then you've got, say, the Russians, who are eternally cash-strapped but have a tremendous amount of rocketry knowledge. I'm amazed that there hasn't been sort of a competition from Saudi Arabia, Dubai, those people, but like built on Russian rocket satellite, rocket scientists with other kinds of electronics and computing, that you would end up with sort of the Middle East as another rocket center. And it's, I guess this is the way that the Saudis are getting into it.
Yeah, all these countries are looking past oil. I think they see that the world will not be reliant on them for tremendous amounts of crude oil for decades to come. And they're looking to jumpstart their technology sectors, jumpstart their science and engineering. And so maybe they could more easily contract with Russia or with SpaceX to launch their stuff, but that doesn't generate a workforce of technically inclined, highly trained people in their own country. And so they're all looking for ways to get in on this future of technology in the bite-sized bits that they can afford to do while they're still heavily reliant on oil and shipping that around the world.
Yeah. Man, I'm still, I mean, it's like competition is always a good thing. If they're going to spend that money on making reusable space tourism happen, I'm down with that. I permit them, is what I'm saying.
It's very gracious of you.
It really is. It really is. Well, let's move on to your story, Kimberly.
Sure. So I return, as I often do, to one of my favorite spacecraft in the solar system, which is the Dawn spacecraft, currently in orbit around Ceres. And one of the new findings from this spacecraft is that Ceres, which is either the largest asteroid in the asteroid belt or our closest dwarf planet to Earth, Ceres might have once had a global ocean.
What?
According to data from the Dawn spacecraft. And this comes from two different independent lines of evidence, both collected from Dawn. The first is a map of the composition of Ceres' crust, which is made primarily of it's a combination of different ices, salts, and other hydrated minerals. And these hydrated minerals occur all over the surface in such a way that it indicates that there was probably a lot of water all over the surface at one point in Ceres' past. The other line of evidence is a global map of Ceres' gravity and the different high points and low points in the gravity on the surface of this dwarf planet. And essentially what it shows is that even though there's a hard crust on the outside of Ceres, just below that there's probably a soft, deformable layer just below the crust. That means there has to be a lot of liquid down there that's keeping things nice and pliable and movable. And so that's where they think all of this water probably ended up, just below the surface, smoothing things out a little bit and keeping things nice and lubricated. Which is so cool. It's a tiny little dwarf planet with a past global ocean.
Yeah, I mean, the mass of Ceres is a fraction of the mass of the moon. I forget how this goes.
Yeah.
If you took all of the objects of the asteroid belt and mashed them all together, you get an object with, I think, 5% the mass of the moon.
Yeah, people have a
tiny.
Slightly skewed idea of what the asteroid belt is. It's pretty sparse. There's not a lot of mass there. Ceres is by far the biggest thing, and it's still so very tiny. And the fact that this tiny world that is smaller than most moons that we see in the solar system could have had a global liquid ocean in the not too distant past is a pretty amazing thing, I think.
So I'm starting to think that with hindsight, now that we've found a bunch of global oceans or evidence for past global oceans in the solar system, that we should have seen this coming. because we know sort of two basic things about the early solar system. One is that there was water everywhere. It's all over Earth. And in the outer solar system, it covers essentially every object. Every moon of Jupiter, every moon of Saturn, Uranus, Neptune, they're covered in ice. And we know that there was a lot of heat around in the early solar system. Heat of formation from all these things smacking together to build up the big bodies that we see. And then short-lived radioactive elements that were breaking down, releasing a bunch of heat early on in the solar system. And if you take a lot of heat and you surround it with a bunch of ice, it doesn't seem like we should have been so surprised that you got a bunch of oceans, because it doesn't take a lot of heat to melt the ice, and the outer layers are going to be a good insulator. And so it wouldn't shock me if we keep finding this over and over and over again in the solar system, that billions of years ago, there were liquid water oceans everywhere. And then only in the largest bodies, or the sort of most special bodies, like say Europa or Enceladus, did those oceans persist to the present day.
Sure, and I think one of the critical things here is that the presence of some sort of liquid water is really key towards keeping up any sort of geological activity on these planets and tiny dwarf planets, and getting that recycling of material from the surface to the interior and back up again. That's how you keep a planet alive, and that's how you keep it moving. That's the part of the reason why Venus has sort of gotten locked up and it's no longer habitable. Mars doesn't have any plate tectonics, but we see that even on these tiniest of worlds, as long as you have some water, you can have geologic activity. And we saw that on Pluto, and we've seen that on Jupiter's moons and Saturn's moons. It's one of those really key things. And because we keep finding it on these tiny little worlds, it gives me a lot of hope for exoplanets, in that these conditions are probably ubiquitous.
So then how long did it stick around for?
It probably stuck around for anywhere from 1 to 2 billion years before the dwarf planet eventually cooled enough, and the water, enough of the water made its way subsurface that the process slowed down. So that we've seen lots of evidence from Dawn already that some of this liquid water must still exist. It upwells as these bright salty deposits, like we saw in the brightest spot in the middle of Okator crater. And we know the water still exists. And so it probably only disappeared about a billion and a half years ago or so from the surface.
So, I can't help but be excited for the potential for life. A billion years, there was life on Earth when there was liquid water on Ceres, right?
Sure. Yes.
Life on Earth stretches back, at least 3.5 billion years. And, if you kind of squint and look sideways at it, you can imagine life hundreds of millions of years earlier than that. As soon as Earth was a habitable place, there was life on Earth.
Astro B asked in the chat, how can Ceres have an ocean that far from the sun? It couldn't have been hot enough.
So one of the things that we've mentioned before is that the water, it's not pure water. It's not just, pure drinkable water. It's heavily mixed with different salts, which actually lower the freezing temperature of water. It keeps it liquid, even though it's not within the 0 to 100 degrees Celsius that we think of liquid water here on Earth. So it's just, a factor of mixing. Think like throwing salt down on your driveway in the winter. It changes the properties of water when you mix those things together.
Well, and the sun is not what keeps the insides of planets warm. The Earth has a molten core and spinning about, and that's what gives us our magnetic field. But it's not molten because we're close to the sun. It's molten from a combination of heat left over from the beginning of the solar system, when all the bits that made up the Earth smashed together. And if you smash things together, you generate a bunch of heat. And those breakdown of radioactive elements sequestered within the core of the Earth. If you took the Earth today and you moved it to Pluto's location, you would still have a hot interior to the Earth for billions of years, because there's enough stuff in there to keep it warm.
Right. And out at Jupiter or Saturn, you get liquid interiors because the giant planets are tugging the moons back and forth. They're stretching it a lot. That creates more internal heat there, too. So, liquid water everywhere.
Especially as we go back in time in the solar system. All right. Well, I'm going to do my part of this show. Since Paul Matzeto's not here for me to hide. So today there was a Senate confirmation hearing for a bunch of folks who are going to be, I guess, working for the government. And one was the President Trump's administration's pick for the head of NASA. And this is a guy named Jim Bridenstine. And Bridenstine, yeah, and so Bridenstine is not a scientist, which is very sort of important to understand. His background is that he's a businessman, was the head of the Air and Space Museum in Tulsa, as part of the U.S. Navy Reserve, flies fighter planes, so I guess he understands that part of it.
He's currently a congressman.
And is currently a congressman from Arkansas? Yeah, Oklahoma. And I guess so as part of this sort of confirmation hearing, they grilled him, and a lot of what they grilled him about was his sort of stance on climate change. And in the past, he's made fairly ambiguous comments about climate change. And today, they really kind of sort of took the questions very, very carefully and very seriously. But the gist of the answers was that he believes in human-caused climate change, that he believes carbon dioxide is a greenhouse gas, that humans are contributing to it, but was still a little wishy-washy on whether he believes the scientific consensus that human beings are absolutely causing climate change. So I think where that stands, he's definitely not a climate change denier, as we would kind of expect. But
at the moment,
in the moment, and that is, I think, the best we can hope for. But on the flip side, he is absolutely a proponent of human space flight. Has been quite engaged in that. Wrote a very interesting sort of series of opening statements about where he thinks NASA could go, and this all sort of dovetails with all of the new announcements that are coming out of the Trump administration, with Mike Pence giving his big talk at the beginning of October. I just got an announcement that they've awarded the next some of the next contracts for the Deep Space Gateway. So that's all still moving forward. So right now, up until the Democrats changed the system, you needed 60% vote to confirm someone like a NASA administrator, and then the Democrats changed the rules to 50%. So in theory, the Senate, with the Republican-led senators, can actually just vote him and the other candidates in. So this is where we stand right now.
Bridenstine has support from both sides of the aisle. I describe him as a pretty traditional candidate for a position like NASA administrator, and he's a huge supporter of commercial space. So if you're a fan of SpaceX or Blue Origin, as a congressman, he wrote a bill that never got a vote in the House of Representatives that basically would have told NASA that if there's a commercial space flight available to do the thing that you needed to do, you should use that. It's cheaper for the taxpayer. It promotes external development of these technologies, and it supports U.S. leadership in outer space. And so he presumably will continue policies like that as NASA administrator and be a friend to companies like SpaceX and Blue Origin.
Sure, and I mean it's a good thing given that NASA has been directed to devote more of their energy towards Earth science and towards space flight, that you have someone who is a large proponent of those things. The parts that concern me and concern many Democrats in the Senate and in the House of Representatives is not what he has said in the past month about his stances on climate change and about spaceflight, but his long record of denying human-induced climate change in a very public manner, and also his very long record of his opposition for equal rights for women, for immigrants, and for the LGBT community, and the question of whether or not he will end up politicizing NASA on those points.
Yeah. And the question, of course, is just like, how much of that is attempting to get into election, right? And how much of that is what he honestly truly believes? And so that is, and that's the part that I guess we would still find out. It's one thing to make campaign promises and agree with people, and it's another thing to actually make policy once you're in charge. And
Kimberly's right. Kimberly's right, though, that this is, no small thing, because I think people often underestimate the importance that NASA plays in Earth science. Observations made by NASA satellites are the most important and the most comprehensive source of information that we have about the Earth, its surface, its climate, its interior today, more than anything provided by the European Space Agency, more than anything provided by National Oceanic and Atmospheric Administration, more than anything else. And so this is a small part of NASA's overall mission, and certainly the least publicized of NASA's main priorities. But, in some ways, for some measurements, they're the only game in town. And a lot of those observations depend on having continuity from year to year to year to year. So it might be the case that, if those were to disappear for a couple of years, that could seriously disrupt decades of observation about how things are changing on the surface of the Earth, and the atmosphere of the Earth, and the oceans, and in the interior.
Yeah,
and
so right now, go ahead, Kimberly.
I was going to say, even not so much disappear, but if the results and how it can be disseminated or stifled, and how it can be analyzed or stifled, as we're seeing with the Environmental Protection Agency, that could seriously impede decades of research, and as well as the U.S.'s scientific standing in the international scientific community.
Yeah. And I mean, right now, there's sort of no certainty about whether or not he's going to be confirmed, and if not, then who will take over. Right now, I mean, NASA has been without an administrator now for the entire year. So, it's been January 20th is when Bolden stepped down, and we have nobody new yet. They have nobody new yet.
And there's still been no grumblings on a White House science advisor.
Right. So I guess just back to the holding pattern until someone makes a decision.
Yes.
All right. Well, now it's time for our guest. And what time is that at? That was at 53 exactly. All right. Just tell chat that. And then we'll move on. And we're back. All right, so as always, we're trying to figure out how to end these shows. We're looking forward to suggestions from you folks. Last week, I think we talked about stuff we're watching or video games we're playing, things like that.
Haunted houses.
Spooky planets.
Clearly, our ideas are bad. Yep. Give us better ones, please.
But this week, Kimberly wanted to know what telescope you'd most like to visit.
Yeah, if you could visit any telescope that's ever been built, ever.
Right, and I would like to go to the James Webb Space Telescope, which is going to be at the L2 Lagrange point. So that would include a space flight to the L2 Lagrange point to visit the telescope. Please.
Well, I mean, speaking of visits to the L2 Lagrange point, I would also like to go to the L2 Lagrange point, but I would like to bring a couple reaction wheels with me and go visit Kepler.
Oh, poor Kepler.
I'm going to sneak him in my pocket, the screwdriver, and I'm going to fix that darn telescope.
I'm less altruistic than Kimberly is. I think I would like to, and see, unlike Fraser and Kimberly, mine's actually achievable.
Oh.
I would like to go and take a trip on Sophia, the Boeing 747 with a giant hole cut in its side and a telescope sticking out. And they fly it around the world, making telescopic measurements from midair.
So
and that
fun.
just seems like such a cool project, and I'd love to stick my head out the window.
So fun fact,
while going.
If you're a scientist and you apply for time on Sophia and they grant you time, they also grant you a seat on the plane. Fun fact for any scientists listening, propose for Sophia time and go take a trip on probably the coolest telescope on Earth. That's my number 2 choice.
We have we've had people from the Sophia project here on the Weekly Space Hangout, so that you may be able to live your dream, Morgan.
I hope so. If you're listening, send me a ticket. I will fly anywhere and
Sophia time
do
allocation
the thing.
committee.
All right, well, I'll pass that along. All right, well, thanks to I think it's time to wrap up this show. We don't need to go into the long where does everybody find everything? I've been told, but I'm still I can't not do it. I need to be able to shamelessly promote the work that you guys do. Kimberly, what are you working on right now, and where can people find out more?
So people can always find out more by going on Twitter at AstroKimCartier, on my website, KimberlyCartier.org, if I ever get around to updating it, as well as all my professional work on EOS.org, that's EOS.org. I recently published something, so that one's just wrapping up. I haven't started something new yet, but the one I just published was about increased pollution of short-lived chemicals that are damaging the ozone layer near Southeast Asia. So,
Morgan.
Yay, ozone.
Wow, we've been putting together a really cool grant proposal to the National Science Foundation to fund the use of augmented reality in museums. And so we're going to take some of the stuff our guest was talking about and make that happen right now. If only the NSF will give us a few $100,000.
No problem. I'm sure they're good for it.
Sounds doable.
I don't know if whoever's the head of the NSF is coming up for some kind of Senate confirmation. And of course, you can check out my stuff at universetoday.com and a YouTube channel. Let's wrap things up. Thanks to Zach Weinersmith for joining us today. Thanks to the WSH crew for organizing the behind the scenes. Go to wshcrew.space. If you're listening to this show and you're on iTunes, please give us a rating and a review. It will help us find our way to up the charts. And that's it. I think it's time to say goodbye. I'm going to put you guys into the gallery mode. There we all are. Wait, there's 2 of me. There we go. Thanks, everyone. We'll see you next week.
Bunch waving.